Hello and welcome. Our topic for the day is identifying arithmetic and geometry sequences. Let's understand what arithmetic and geometric sequences are first. Arithmetic means that each term changes based on adding. That is, if we add something to the previous term, we'll get the next term. This is called the common difference, and to find the common difference, we subtract the first term from the second term. Whatever is the common difference is it is added to each previous term to get the next term. Now we look what a geometric sequence means. Geometric means each term changes based on multiplication, and how that change is calculated, that is called the common ratio. It is calculated by dividing the second term by the first term. Whatever solution we get on dividing the second term by the first term, that is multiplied with each term to get the next term of the sequence. Let's understand some questions based on the same. The first question says name the sequence as arithmetic, geometric, or neither. So here we are given the sequence -9, -13, -17, -21, -25, and -29. So let's see, we'll find the common difference first. Common difference is subtract the first term from the second term, that is -13 minus -9, and the common difference is denoted by the letter D. This is equals to -13. Negative times negative is a positive, so plus 9. -13 plus 9 is a -4. So this is the common difference. Let's see if this common difference is added to each term, do we get the same sequence as given to us. So the first term is -9, so we add a -4 and we get -13. Now again we add a -4 to -13, we get -17. In -17, if we add a -4, this is going to become -21. Again we add a -4, so this is -21 plus -4. This is equal to -21 minus 4, which is -25. That means this is correct. And again -25 plus -4 equals -29. So this series is matching with the given in the question. So this means that this is a arithmetic sequence because the next term that we got is by adding the common difference, which can be seen in option D. Let's try the next question. Name the sequence as arithmetic, geometric, or neither. So we give a -6, -31 by 5, -32 by 5, -33 by 5, -34 by 5, and -7. So here let's find out the common difference first. If that satisfies, then the series is correct. Then we find the common ratio. Now to find out the common difference, what we do? We subtract the first term from the second. So this is equals to, let's name it as D. This is -31 over 5 plus 6, which is equals to -31 plus 30 divided by 5, which is equals to -1/5. So this is our common difference. Let's see if by adding this term to each of the terms do we get the next term or not. So we add -6 and -1/5. This is equals to, let's do this. This is -31 over 5, so that's the second term. -6 was the first term, so -31 by 5 is the next term. So -31 by 5, I add again the common difference of -1/5 to this. Let's see what we get. This is -31 over 5 minus 1/5. This is equals to negative 32 by 5. This is the third term. Let's see the fourth term. Do we get the same? This is equals to negative 32 by 5 minus 1/5, which is equal to negative 33 by 5. So if we see that this is tallying to what the series was given to us. Let's look at the last term and the last but one. We have negative 34 by 5 plus negative 1/5. This is equals to negative 3 by 34 by 5 minus 1/5, which is equals to negative 35 by 5, and this is equals to negative 7. So this is also matching. So our series is a arithmetic one, because here the next term is obtained by adding the difference. So that means it's an arithmetic sequence. Let's try the next question. Name the sequence as arithmetic, geometric, or neither. So here the sequence is given to us. Let's find out the common difference first. This is equals to negative 15 minus 9. This is equals to negative 24. So the first term is 9. We add a negative 24 and we get negative 15. Now if we add a negative 24 to negative 15, let's see what we get. Negative 15 minus 24, which is equals to negative 39. This is not my third term. The third term in the given sequence is 25, so this is not an arithmetic sequence. Let's find out the common ratio. Common ratio is denoted by the letter R. R is calculated by this, taking the ratio of the second term to the first term. So this is equals to negative 5/3. So my first term is 9. 9 multiplied by negative 5/3. Let's see what we get. This is equals to negative 15. So this is the second term, correct. Now let's look for the next term. Negative 15 times negative 5/3. This is 5. Negative 5 times negative 5 is a positive 25. This is also correct. Let's look at the next term. 25 multiplied by negative 5/3. This is equals to negative 125 over 3. Perfectly matching. Now negative 125 over 3 multiplied by negative 5/3. This is also matching to 625 by 3, which is 9. 3 times 3 is a 9. This is matching to here. And finally the last term is 625 by 9 multiplied with negative 5/3 will give us negative 3125 divided by 27. So we see that using the common ratio and multiplying each term with the common ratio, we got the sequence. So since it's generated by multiplication, this is called a geometric sequence. Option A is the correct one. Let's look at the next question. Name the sequence as arithmetic, geometric, or neither. So the first step, we'll calculate D, that is a common difference. Negative 2/3 minus negative 1. This is equals to negative 2/3 plus 1, which is equals to negative 2 plus 3 divided by 3. This is equals to 1/3. Now let's look at the terms, whether they satisfy with the common difference or not. The first term is negative 1 plus 1/3 will give us negative 2/3. This is okay. Now negative 2/3 plus 1/3 would give us negative 1/3, which is not the third term. So this is not an arithmetic sequence. Let's find out the common ratio, which is equals to negative 2/3 divided by negative 1. So this is equals to 2/3 only. So the common ratio is 2/3. Now we'll multiply terms, each term with the common ratio to find out the next term. So negative 1 multiplied with 2 thirds gives us negative 2 thirds. This is okay. Negative 2 thirds multiplied with 2 thirds is negative 4 ninths. This is also tallying. Negative 4 ninths multiplied with 2 thirds is a negative 8 by 27. Negative 8 by 27 multiplied with 2 thirds gives us negative 16 over 81, and negative 16 over 81 multiplied with 2 thirds gives us negative 32 over 243. All these terms that we found are tallying with our given series, and since it's obtained by multiplication, therefore it is a geometric sequence. Option D is the correct one. I hope identifying arithmetic and geometric sequence is easy now. Thank you for watching and have a nice day.